So here we're going to illustrate the idea of a solid solution. Now we'll start out with something a little bit more familiar. Let's say we have a cup of water. So there's a cup here and we'll fill it with some blue material, H2O. So we've got a cup of water, and then we can consider the case of adding some salt crystals. So let's have a little cube of salt, some sodium chloride, and we'll drop it into the water, and then those sodium and chloride atoms will dissolve out to form a solution. So what do we have here? We have a single phase, a liquid. And in that liquid, we have a mixture of H2O plus sodium chloride due to the halite that we've dissolved into it. Now, we call it a single phase because we cannot separate these two by mechanical means. We have another YouTube video where we define a phase, and a phase is something that is mechanically separable. We cannot use mechanics to separate water and sodium chloride that are dissolved together in that liquid. However, we could use chemical means. We could try boiling off the water, and if we boiled off all the water, then we would be left with a cup with a bunch of sodium chloride residue down here at the bottom, some salt crystals down at the bottom. Well, what we did with liquids, we can also do with solids. So here's a very nice diagram by Dexter Perkins in his online textbook on mineralogy. The blue atoms here and green atoms are going to come together to nucleate and grow a crystal. And if we follow the arrows, we end up here, and we end up with this crystal, which is again a single phase. This is one mechanically coherent piece of material. Let's just say it's halite, so we'll call it sodium chloride. We'll say that the chlorine atoms are the green fellows here, and the sodium atoms are those blue fellows there. Let's add something new to the mix. Let's say instead of blue atoms, let's say we have some red atoms of potassium. So we'll have some potassium atoms over here, and we'll add them as we move around the circle to make this crystal. So we have some potassium atoms, and they have a 1 plus charge, and we can compare that to sodium that also has a 1 plus charge. Because they have the same charge, we can bond potassium to chloride ion just the same way we bond sodium to chloride. And when we do this, we get the mineral sylvite, and when we bond chloride with sodium, then we get the mineral halite. Well, these two things need not be separate crystals. If we have potassium atoms that are competing with sodium atoms for their place inside this crystal, then as this crystal grows, some of those blue guys, we could just paint them red. We'll make a couple of these red, make this one over here. Some might be close together, some might be far apart. Most of them will probably be far apart. The potassium atom is a little bit bigger than the sodium atom. We'll just draw in a couple over here and another over there. So the radius of potassium is greater than the radius of sodium. And so that'll cause a little bit of distortion in the shape of this cube. And if we try to add a lot of potassium, it could cause some energetic problems in terms of keeping the crystal together. But let's say we just have a few potassium atoms that we want to sneak into that structure. By charge balance alone, it's really not a problem. And the radii are close enough that we can dissolve them into that structure. So what we've done is created a single phase here, right? That single phase is this crystal right there. We cannot separate these by breaking the material apart. There's no mechanical means that will allow us to draw out the potassium atoms and just leave behind the sodium atoms. Now, we might be able to do it through chemistry. We might be able to find a special kind of liquid that'll draw out the potassium and leave those into some kind of liquid solution, and then leave the sodium atoms concentrated behind, just leaving the halite all by itself. But without that process, we would have this intimate mixture of potassium and sodium atoms filling in these spaces in between the chlorine atoms, would have a single phase dissolving both potassium and sodium atoms, and that would be an example of a solid solution. A single solution, in this case here, a single phase, the way we've illustrated, it's actually a single crystal that dissolves two components, a sylvite component and a halite component. So we would have one phase, we would have to call it a different name. We could simply call it a chloride mineral of some kind, and that chloride mineral would have two components. It would have potassium chloride and sodium chloride components. This is the beginning of our introduction of the idea of components, which we'll look at later in other videos.